Okay, so a movie stunt driver on a motorcycle speeds off horizontally on a 50.0 meter high cliff. How fast must the motorcycle leave the cliff top if it is to land on the level ground below 90 meters from the base of the cliff? So the first step to solving these problems is to draw a picture. This is my motorcycle rider. This is the cliff. And that's the 90 meters. I do expect a drawing for your exam and your study guide, but also if you ever need to solve a problem that requires you to know how fast an object needs to go, maybe it's jumping off a roof into a swimming pool, or maybe you do ride a bike one day, or a scooter or skateboard, and you need to clear a specific distance. Hopefully you're never running from building to building like they do in the movies, but you might find yourself needing to jump over or ride over a space. Now I do expect you to label your drawing as well. That's 50 meters. And this is 90 meters. And I left off the 0 because it's negligible. If it was 50.1, definitely include that. 50.7, include it. But this example, we can just stay with our basic numbers. And for your exam, I'll also just have basic numbers. I wouldn't have it as decimals to the tenths. All right. So you've got your drawing. You've got your big picture. The question is asking how fast does the motorcycle have to go? So that's your final velocity. And here we have two x's. You have x, that's your height, and x, that's your length. Now, what I was taught is you should start using the variable y and x. But when I was putting the lesson together, it started to get very confusing what I meant by y, what I meant by x. So just for this introduction to high school physics, we're just going to call it x1 and x2. That way we can just use the same equation instead of looking for the y equation. Where's the y equation? It's actually just one type of x and another type of x. And I made mine negative 50, because the bicycle rider is not at the bottom of the cliff, but at the top, and is returning back to Earth. Right? Anytime you go down in elevation like gravity, it's going to be a negative value. So even though my drawing doesn't show negative 50, your information that you list out should say 50. Acceleration is the same as always, gravity, negative 9.8 meters per second. And we want to solve for velocity. Now, how many of you took a class with a teacher named Dr. Wadiko? Anybody? Dr. Wadiko? Okay. So Dr. Wadiko gave me a really good tip about teaching equations that have 3 variables. Not anymore, just 3. And that is to put them into a triangle. And whenever you have this triangle, you could find out and predict what equation you're going to use. Like v is going to equal x over t, x equals v times t, and t equals x over v. So you have to shift a little bit of where the variables are in your mind, but if you look and use your imagination a little bit, you can actually see it. The v is the x over t. Your x is the vt, and your t is the x over v. It kind of looks like a t, but that's an x. So it's a nice device as long as you know which letter goes where in the triangle. If you don't remember that, then forget the triangle. Okay, but we can use this for now. Now we want to find the velocity, but we don't have time. Well, we don't have t. We have plenty of time in class. We don't have the variable t. So what we're going to do is make t the unknown and plug it into an equation so we can start using this triangle. So it's a two-step process. If you did the waterfall, you will recognize the equation we're about to use to find t, and then we will use that t for our v. So you'll need this equation. Final distance equals initial distance plus initial velocity times time plus half times acceleration times time squared. I did not expect you to memorize that and put that into the problem immediately. It is something that you have to correlate with on your notes. And if you ever come across this type of problem, you can use this equation. So we just plug in. Negative 50 is our final distance. So that's how far the motorcycle needs to drop. Now, we're not looking for the time it takes to land at the end of the 90 meters, because in theory, it's supposed to be the same. When you launch off the cliff and land versus just fall off the cliff and land, it's supposed to happen at the same time, as long as your air resistance is equal or there's no air resistance. So we're going to use 50 instead of 90, because we want to know how long it takes for the bicycle to drop. And once you find that out, then you can find out the speed it takes to make the landing. Is there a Jelani Johnson? Let's see. Maybe she had DD2? Let me check my roll. Maybe she's a new student. I mean, she wouldn't be here today, but she is on this pass. Let's see. J. Nope. Maybe DE2. All right. So we've got our variables plugged in. Now we just need to calculate. It's going to be period 3. So Eduardo, grab a calculator, and when we simplify this equation, it becomes negative 50 equals negative 4.9 t squared. And what would you put in your calculator, Eduardo, to solve for t? What's the first step? Divide. And the reason you want to cancel what out? Okay. So you want to leave the t alone, but cancel out the 4.9, the negative 4.9. So in your calculator, give us negative 50 divided by negative 4.9. And go ahead and continue our calculation. How do I cancel out the square root or square? I just said it. Okay. Yep. What do you get? And do that for us. $3.19. So that's the first answer we need. The second will be plug it into the shorter equation. Now when we plug it into our triangle where v equals x over t, we get the values. This time it's 90. And why is it 90, not 50? Because this time we're trying to calculate what it takes to clear the 90 meters. Not fall off 50 meters, clear the 90 meters. That's the original question. So 90, and then 3.19 is what we got from Eduardo. Let's ask Pedro Mendoza. Please divide 90 by 3.19. $28.21. And I'm going to start labeling things so I know which answer belongs where. So T that should say seconds. And then 28.21 is my meters per second. That way, when I do these problems, it has a little bit more meaning. I can tell, okay, I just found time, and now that I found time, I can plug it in to find velocity. But that's how you do the first physics problem for today.